Guys, good evening. You are welcome to my YouTube channel, the Explicit Tutorials. As you all know, I'm Tutor Joseph or Mr. Explicit. Please, as you watch this video, endeavor to subscribe, like, share, and comment. We are still discussing the part 2 of organic chemistry, and of course, this is the conclusion of the topic. And we have treated about 15 exam likely questions already, and today we shall be looking at additional questions on isomerism. The first question said propanal and propanone possess dash isomerism. Propanal and propanone possess dash isomerism. Please, propanal and propanone possess functional group isomerism. Why? It is simply because the both of them have the same molecular formula but from different functional group. From different functional group. That is to say that propanal is from acanal, but propanone is from ether. Alright, so they belong to what? Functional group isomerism. Now, ethanol and methoxymethane possess dash isomerism. The answer is still the same as functional group isomerism. Why? It is simply because ethanol is from acanal functional, it possesses acanal functional group, while methoxymethane possesses ether functional group. All right, so that is the answer. Number 3, propanol and glycerol possess dash isomerism. Propanol, also called propan 1-ol, and glycerol, also called propan 1,2,3-triol. They possess position group isomerism. Why? Propanol, the OH is found at carbon 1. That is why it is called propan 1-ol, okay, or propanol. But glycerol, the OH is found at carbon 1, 2, and 3. Propan 1,2,3-triol, also called glycerol. So they possess position group isomerism. Number 4, there are dash types of isomerism. There are 2 types of isomerism. That is D. That is, we have the structural isomerism and we have the stereo isomerism. Number 5, which of these isomerism possesses chiral center, or don't they call chiral center? It is the optical isomerism. The optical isomerism possesses the chiral center. 6, cis and trans isomerism are geometric isomerism. D. Cis and trans isomerism are geometric isomerism. All right, so please take note of that. It is cis when the group in question are at the same side, and it is trans when they are found at opposite sides. Take note of that. Number 7, which of these have the ability to rotate plane polarized light? Which of these have the ability to rotate plane polarized light? The answer is optical isomerism. Please, a compound is said to be optically active when it is able to rotate plane polarized light. So the answer is C, optical isomerism. Number 8, mirrors that form images of each others are called enantiomers. B. Mirrors that form images of each other are called enantiomers because they can rotate to the left, called level rotatory, or rotate to the right, called dextro rotatory. Please take note of that. Number 9, mirrors that do not form images of each others are called diastereomers. That is option A. Mirrors that do not form images of each other are called diastereomers. Option A. Number 10, a mixture of enantiomers is called racemate. C. If I don't call it racemate, I also call it racemic mixture. Okay, a mixture of enantiomers, that is the combination of 2 or more enantiomers, is called racemate or racemic mixture. Please take note of that. Number 11, which of these is used to differentiate enantiomers? A. Physical change. B. Chemical change. C. Decomposition power. D. Ability to rotate plane polarized light. You should note that enantiomers have the same physical and chemical properties, but they are differentiated by the ability to rotate plane polarized light. So the answer is option D. Number 12. Which of these is false about diastereomers? A. Similar chemical properties. B. Different physical properties. C. They are separated through fractional distillation and chromatography. And D. None of the above. The answer is none of the above. Why is it none of the above? It means that option A, B, and C are all correct about diastereomers. That is mirrors that do not form images of each other. It therefore means that diastereomers have similar chemical properties and they have different physical properties. They are separated through fractional distillation and chromatography. Take note of that. Number 13. The Larsen sodium fusion test is used to determine which of these elements: A. Sulfur, B. Nitrogen, C. Halogens, D. All of the above. The answer is all of the above. The Larsen sodium fusion test is used to determine sulfur, nitrogen, and halogens. You know the halogens are the group 7 elements, which are the fluorine, chlorine, bromine, iodine, and what? Astatine. So all of those group 7 elements are collectively called halogens because they form salt. Hence, they are called salt formers. Okay. Number 14. Which of these is true about enantiomers? A. The same chemical properties. B. The same physical properties. C. They are differentiated by their ability to rotate plane polarized light. D. All of the above. The answer is all of the above, meaning that enantiomers have the same physical and chemical properties and they are differentiated by the ability to rotate plane polarized light. If you know you have not subscribed to my YouTube channel, do so for a better understanding and so that when I upload the new content you will be notified by YouTube. Do have a wonderful day.